Hello, everybody. Yeah, we're still on chapter number 8, and this happens to be our last section. Okay, for the semester, this is what we have to look at for the very last time. All right, so here we are looking at equations in Cartesian coordinate system. Now, students will be able to understand and explain equations of lines. Is that okay? So for equations of lines, basically, we are looking at the linear equation, which is y is equal to mx plus b. You may have come across this under in your algebra class or in Math 123 quantitative reasoning. And then we will look at the slope of a line and the slope formula. So this is it, and this guy is the slope. We know m is always your slope, and this is your what? Y-intercept. So we shall look at this in detail as we move along. And then graphic and algebraic solutions for systems of linear equations. All right, so we look at how you can use a graph to simplify a simultaneous equation. All right, and then ways to determine if a system of linear equation has a unique solution, infinitely many solutions, or no solution. All right, so let's get into the conversation. Now, the Cartesian coordinate system. The Cartesian coordinate system enables us to study both geometry and algebra simultaneously. All right. Now, a Cartesian coordinate system is constructed by placing two number lines perpendicular to each other. Right. So we are going to look at what it is. So this is what we call the Cartesian plane. Okay. So we have our x. Okay, our x, and then we have our y-axis. Is that okay? Now, when I put numbers in coordinate form, whatever comes first represents our x coordinate, and then what follows represents our y coordinates. Are we familiar with this? Okay, nice. So if I have 3, 4, that means 3 on the x and 4 on the y axis. Okay, so therefore I'll have that. So 3 on the x and 4, and I have to pull them together, and I have 3, 4. We know how to do this, don't we? Right. So we have this as the first quadrant, the second, the third, and the fourth. All right. So this is what we call the Cartesian coordinate system. Now, and we know how to do that, and that is what I've taken you through a while ago. All right. So here, now every point on the x-axis has a y coordinate of 0. Okay. Every point on the y-axis has a coordinate of 0. So we are going to look at what this really means. All right. So the x-axis has equation y is equal to 0. All right. So that is what we call, we're going to look at what we call the x-intercept and the y-intercept. Is that okay? Now on the x-intercept, okay, where the line cuts the x-axis, y is equal to 0. On the y-intercept, so this is what we call x-intercept. So x-intercept is where the trend line cuts the x-axis, and this is what we call the y-intercept. And the y-intercept is where the trend line cuts the y-axis. Okay, so let's look at this. So here we're going to sketch the graph x is equal to 2. So for x is equal to 2, we are saying that at this point, this is x equal to 2. So if you wanted to name this point, this would be what? 2 and 0. Okay. So this is the point we call so 2 is the what? Is x-intercept. So, and the x-intercept y is what? The value of y is 0. Is that okay? And then here, we do the same thing. So this is just a straight line along the y-axis. Is that okay? And that is what we call. So this is x-intercept, and that is y-intercept. Okay. And here, if you wanted to put this point together, you realize that your x should be a 0 and your y is a 3. Okay, nice. So basically, that is what we're doing. So now you have less than, and when you have a less than symbol, you do not shade this. Okay. Now, if you have on the flip side, if you have this, your arrow should be shaded, and it should go this way. If you had that, that should have been shaded here, and then it goes that way. Okay, nice. Now, equations of vertical and horizontal lines, and we have looked at that. Go. Now, all points corresponding to arithmetic sequences lie along the lines. So here you just have to sketch, okay, these equations, and that is the line you have on the Cartesian plane. Right. Now, the slope of the line, usually represented by m, is a measure of steepness. Okay, so we're saying that if you have an equation, so let me give you an example of this. So m is greater than 0. So you know that the equation of a line is y is equal to mx plus b. Okay, and m is the slope and b is the y-intercept. Now, when m is greater than 0, so if you have y is equal to 2x plus, say, let me say 3, okay, this slope is positive. So if you plot this, you're going to get a graph like this. Now, this means that as the values of x increase, okay, the values of your y also what? Increase. Is that okay? Now here, this is, if I'm going by the same thing, mx plus b, this means that our slope is 0. So for instance, if I have y, and this is an example of such equation, let's say if this is 0, so 0x plus, say, 3, I'm going to get y being equal to what? 3. So I'm going to get a straight line. Okay, and we looked at as a typical example like that in the previous slide. Now, so if I have another equation, y using that, okay, now this means my slope is negative. And when my slope is negative, I'm going to do that 2x plus, say, 3. And I'm going to get an equation, a line like that. So this is my y and that is my x. Okay, this means that the slope is what? This has a negative slope. It is trending downwards. Okay, this means as x increases, okay, as x increases, y is decreasing. Okay, or the reverse. Is that okay? And that is how these will look like. All right, now find the equation of the line that contains that. All right, the coordinate 0, 0, and you have 2, 3. Now the line passes through the origin, right? Because the origin is the point 0, 0. So we're saying that y will be equal to what? Mx. That means that it passes through the origin. The origin is what? 0. So we have y is equal to mx plus 0. All right. Now what you can do here is that you can substitute, because this is your x and that is your y. If you substitute 2 for x and 3 for y, your equation now becomes that, and then you simplify that. So your m is 3 over what? 2. Now you plug that into this equation and you have y is equal to 3 over 2x. And that is what? Your equation. Is that okay? Nice. Now, for a given value of m, the graph of that is a straight line through x is 0, right? And you have your b, and a parallel to the line whose equation is equal to that. So really, if you wanted to do that, so here, this is 2 equations. Now, this means that an increment of 2, right? You see that? And this decreases by 2 because of this value. Okay, so, and this is the equation that passes through the origin, y is equal to x. Now, what this here means that this is telling you that what actually happens here, that is the difference you have right there. Okay, so depending on what you see there, okay, when you have m to be 1, that is what is reflecting on towards your right side. So b is a distance. So any 2 parallel lines have the same slope or are vertical lines with no slope. Okay. Now the graph of y is equal to mx plus b crosses the y-axis at a point that, okay, that is what we call the y-intercept, and I've mentioned that. Okay, and where it crosses the x-axis is what we call the x-intercept. I already mentioned that. right? Nice. Okay, so given that the equation y minus 3x is equal to minus 6, we want to find the slope. So all you need to do is to rewrite this in the form y is equal to mx plus what? Plus b. So you have y minus 3x minus 6 is equal to minus 6. So you have to rewrite that, and then this will be what? 3x minus 6. Now, if you compare this and that, your slope is 3, and your intercept, your y-intercept is minus 6. And that is all you do. Okay. So you just rewrite the equation in the form y is equal to mx plus b and choose your m. And that simplifies that. Is that okay? All right, nice. So to find the x-intercept, we know that for x-intercept, y is what? 0. So you put y to be 0, and then you solve for your x. And that is why we have the x-intercept being 2. All right, so here you can put this on a line. So the point 0, negative 6. So that means 0 on the x, negative 6 on the y. That's that point. Okay, and then 2, 0. So 2 on the x, 0 on the y. And you draw a straight line through, and that gives you that line. So every line has an equation of the form y is equal to mx plus b, right? Where m is the slope. And the equation, which we already know, right? So y is equal to mx plus b is our linear equation. Now, let's talk about how you can find the slope given a pair of coordinates. So when you're given a pair of coordinates, okay, this is how you find the slope. So either that, or you can do m being equal to y1 minus y2 over x1 minus x2. Now look at this. If I have x1, y2 here, this must be what? X2. And then y1 there, this must be x1. On the flip side, if this is y1, this must be x1. And make sure you don't flip it. All right, I've seen students do x over y, which is not the case. So the slope is what? The rise or changing y over the change in x. And that is a measure of the steepness. Okay, nice. So here, if we have this pair of coordinates, this is our x1, that is y1, x2, and y2. And now we put them in the equation y2 minus y1 over x2 minus x1. So just plug these values there. Okay, and that gives you that as your slope. Is that okay? Nice. So that's basically how that works. Is that okay? Nice. And you can find the equation of the line. The value of your y1 usually will be the value of your b. Now here, so basically now we are done with the linear equation. Now we want to look at systems of linear equations. So the mathematical descriptions of many problems involve more than one equation, each having more than one unknown. To solve such problems, we must find a common solution to the equations, and if it exists. So here we are going to look at simultaneous equations, right? And the first approach we'll be looking at is how we can solve simultaneous equations graphically and how we can apply two other methods. One method talking about elimination, okay, and the other talking about substitution. All right, so if you read that problem closely, we use these equations, and where after you know how to plot the lines, right? Now, when you do that, where the two lines intersect, and they intercept at the point 2, 1, and 2, 1 becomes the solution for the problem. This, all right? Nice. Is that okay? Nice. So here, we are actually applying our knowledge in linear models, all right, to simplify a simultaneous equation in two variables. Is that okay? Nice. Now, there's another way to do this, okay? And That's what we call substitution. And these are the steps you go through to use substitution. So for the substitution method of systems of equations, what you do is that you make one variable the subject. Okay, so these are the two equations. So you make one variable the subject in either equation 1 or equation 2, and you insert into equation number 2 to find the other variable. Is that okay? So you make S the subject from equation number 1 or equation number 2, and then you will substitute that into the other equation, and that's you solve for the two variables, and that makes it really very simple. Okay, now the other method we want to look at is the elimination method. And the elimination method, just as the name implies, we want to take out or we want to eliminate something. All right, so what you do is you have to make sure this equation has the same values in equation number 1, in equation number 2 for any of the given variables. So your goal is to make maybe the coefficient of x and the coefficient of y the same, so that you can subtract to eliminate. You can add or subtract to eliminate. Is that okay? Or you make this and that the same by adding in this case, or subtracting in a different case, and you put that together to solve for the other. Does that make sense? So I'm assuming you may have an idea how this works. So here, and you always do that by multiplying by a factor. And when you multiply by a factor, it makes one variable or one coefficient the same, and then you add or you subtract based on the given problem, and you find the other. Now, when you have found that, you substitute into the other equation to solve for the other variable. Is that okay? And that is how systems of equation works. Is that okay? So here, this is solutions to systems of linear equations. So geometrically, a system of two linear equations can be characterized as follows. The system has a unique solution if and only if the graphs of the equation intersect at a single point. Now, the system has no equation if and only if the equations represent parallel lines. So when the equations have two parallel lines, that means that it has no solution. The system has infinitely many solutions if and only if the equations represent the same line. Okay, and that is how you go about systems of linear equations. Okay, nice. So basically, that is all we have to go through for this course. And thank you very much for your time. All right, and we'll see you soon. All right, thank you very much, and bye-bye.